In this video for section 5.6, we're looking at conditional probability. And we talked in section 2.3 about conditional distributions, and what that means is in our contingency table, if we restrict ourselves to just looking at one row or one column of the table, then that's the conditional distribution. If we want to calculate a probability based on a conditional distribution, it's called a conditional probability. And we have special notation for that. It looks like this with the vertical line. And this is read as probability of B given A. And what that means is that the event A, whatever characteristic A is, that is assumed to be true. And so that tells us to restrict ourselves to just looking at the row or column where A is true for everyone. So we're going to look at some examples. The first one is, what is the probability that a randomly selected customer who is a woman wants an MP3 player? So looking at my table, I can see the number of women who want an MP3 player is 130. And then I know that the customer is a woman. So that tells me that I'm restricting my data set to just looking at the row that lists the responses of women. So I'm going to divide by the total number of women, which I can get from the table. That's 251. So my answer would be 130 divided by 251, which as a decimal is approximately 0.518. So that tells me that a little bit over half of the women customers said that they would like an MP3 player. Question 2 says, what is the probability that a selected customer wants a bike given that we have selected a woman? Now, this is the same as question 1, it's just phrased a little bit differently. So we want to know the number of women who want a bike out of the total number of women, because this given that we have selected a woman means that we know that the person who we've selected is a woman. And we want to know the probability that they will want a bike if we know that they are a woman. So this would be number of women who want a bike, which going to my table was 30, divided by the total number of women, which was 251. And as a decimal, that's approximately 0.120. So if we know that the customer is a woman, there's a 12% chance that they will have wanted a bike. Question 3 is written in the notation with the vertical line, and this is, what is probability that a randomly selected customer is a man given that they want a camera? And so that they want a camera, that's the part that we're assuming to be true. So we're going to restrict ourselves to just looking at the set of people who want a camera. So that would be this column right here. So if we know that they wanted a camera, what is the probability that they are a man? Well, there were 50 men who wanted a camera out of a total of 141 people who wanted a camera. So this is number of men who want a camera divided by number of people who want a camera. And there were 50 men who wanted a camera out of a total of 141 people, and that's approximately 0.355. Now we're going to look at another example here that has to do with color blindness. Men are more likely to be colorblind than women, and we have in this table proportion of people who are colorblind and not colorblind separated by gender, so men and women. And our first question here is, what is the probability that a randomly drawn person is colorblind given that the person is a man? And so one thing to notice about this table that's a little bit different than the previous table is that instead of numbers of people in the boxes, I have proportions or percentages. And so for example, this is telling me that 4% of the population are men who are colorblind. So to calculate the probability that a randomly drawn person is colorblind, given that the person is a man, that tells me I'm restricting myself to the men column. Now, the information that I need here that I don't have is I need the total of the men column. So I need to add those two together. So if I do that, 0.04 plus 0.47, that gives me a total of 0.51. And so this is going to be probability of being colorblind and a man out of the total probability of being a man. So that would be 0.04 divided by 0.51, which is approximately 0.078. Question 2, given that a randomly drawn person is colorblind, what is the probability that they are a woman? So now, my given is that they are colorblind. So the total that I'm going to look at, or the number that's going to be in my denominator, is going to be the total number in the colorblind row. That tells me that I'm restricting myself to the colorblind row. So I need to add these two numbers to get the total. So that would be my denominator, 0.04 plus 0.002 equals 0.042. And then the question is asking, what is the probability that they are a woman? So the total women would be the 0.002. So 0.002 are women who are colorblind divided by the total who are colorblind, 0.042, and that gives me 0.048. So this is telling me that out of the total population of people who are colorblind, only 5% of them are women. And that's a pretty strong indicator that colorblindness and gender are not independent. Whether or not you are colorblind depends pretty significantly on what your gender is.